Okay, number 3 reduction, very important, which is called Clemenson reduction. Very important reaction. Clemenson is the name of scientist, and this type of reaction which are given according to the name of scientist, these reactions are always important. So Clemenson carried out this reduction, that's why the reduction is called Clemenson reduction. The reaction is like this. This is aldehyde, RCHO. When aldehyde undergo reduction in presence of one special reducing agent which is used by Clemenson, that is zinc amalgam. I mean zinc combined with mercury and HCl is added. This is the special reducing agent used by Clemenson. Then this oxygen completely removed from the compound. As you know, reduction means either addition of hydrogen or removal of oxygen takes place. So here oxygen will be totally removed from the compound and some hydrogen will be joined with the carbon. Ultimately you will get RCH3. Hydrogen is removed from the oxygen is removed from the carbon and 2 hydrogen joined with carbon. Why 2 hydrogen joined? Because you know oxygen valence is 2. When oxygen is removed, 2 hydrogen required, and that oxygen combines with hydrogen, it produces water. Ultimately you will get alkane as the product. You may get ethane, propane, butane, like that, depending on the number of carbon here. Similarly, if you take some ketone, this is one ketone, propanone. When you do reduction in presence of zinc amalgam and HCl, then this oxygen will be removed from it. Hydrogen you added with the middle carbon, you will get the propane. Directly it will convert to alkane. Side product will be water. So if you want to convert aldehyde ketone to alkane, directly you can convert by applying zinc amalgam and HCl, which is called Clemenson reduction. And one thing you have to know, when you symbolize the reduction by writing like this square bracket H, then no need to balance the hydrogen. In product side we have added here 2 hydrogen, here 2 hydrogen, 4 hydrogen you have used. But when you write the hydrogen inside square bracket, no need to balance it. Available hydrogen are present here, so you can add as required. Then another reduction, number 4, which is called Wolff-Kishner reduction. Wolff-Kishner reduction. This is another naming reaction. Wolff-Kishner carried out this reaction, that's why the reduction is called Wolff-Kishner reduction. This is aldehyde, RCHO. When aldehyde reacts with hydrogen, hydrogen already you have got, this is one example of ammonia derivative. Already you have got this reaction, then the hydrogen combines with oxygen to produce water and the remaining part will join like this, RCH double bond and NH2, which is called hydrazone. After production of this, when you apply potassium hydroxide with glycerol, this is the special reagent, then the compound will be converted to alkane. I mean you will get RCH3, and this nitrogen removed as nitrogen molecule like this way, and these 2 hydrogen combined with the carbon, ultimately this one is balanced. So here also product you will get as alkane. Similarly, if you take some ketone like this, suppose you have taken propanone, first time you apply the hydrazine NH2, then hydrogen combines with oxygen to produce water. Water will be removed and this part will combine with each other, double bond and NH2, which is called hydrazone. If you apply potassium hydroxide and glycerol, so this part will form one alkane. Ultimately you will get CH3, CH2, CH3, which is called propane, and nitrogen will be removed from it. So this Clemenson reaction and Clemenson reduction and Wolff-Kishner reduction, in both the reaction aldehyde ketone is converted to corresponding alkane. Only the difference is in Clemenson reduction they use zinc amalgam HCl as reducing agent, and Wolff-Kishner use potassium hydroxide and glycerol as reducing agent. So these are about reduction reaction. Number 5, another reduction. Reduction with I mean hydrogen iodide in presence of red phosphorus. Red phosphorus means it is the allotropic form of phosphorus. Phosphorus can exist as white phosphorus, yellow phosphorus, red phosphorus, different form of phosphorus you will get, and here you have to use the red phosphorus. The reaction is like this. This is aldehyde. When it reacts with HI, hydrogen iodide, in presence of red phosphorus, then the aldehyde is directly converted to alkane. Side product you will get iodine and water. If you want to balance the reaction, you write 4 here, then you write 2 here, then the reaction will be balanced. In organic chemistry, no need to balance the reaction. So this is another type of reduction. Now another reaction, this is not reduction, this is called halogenation reaction. Halogenation reaction. I mean halogenation means nothing, addition of halogen. This is one of the aldehyde, CH3CHO. When you apply halogen like chlorine, bromine like that, in presence of some acid, or you can write H plus also, H plus represent acid. You know this is the functional group, aldehyde. From the functional group, the next carbon is called alpha carbon, next carbon is called beta, next carbon is called gamma carbon like that. So here alpha carbon is present and these hydrogens are called alpha hydrogen. I mean the hydrogen which is joined with alpha carbon, they are called alpha hydrogen. When you apply halogen in presence of acid, then the alpha hydrogen will be replaced by your halogen. Ultimately you will get CH2Cl CHO, 2-chloroethanol. Similarly, if you apply again chlorine in presence of acid, another hydrogen will be removed by it. Ultimately, 1 by 1 hydrogen will be removed by chlorine, and since halogen is joined with the carbon, that's why these reactions are called halogenation reaction. So reduction, you have got 5 reduction. Among that, the Wolff-Kishner reduction, Clemmensen reduction, these are very, very important for exam. Mainly you should know about the reagent. Zinc, mercury, HCl, similarly magnesium, mercury, HCl. When you see this reagent with aldehyde and ketone, then always you have to know they undergo reduction and they will produce corresponding alkane. So only the reactions are given to you, product you have to write. I mean complete the following reaction. So that is why you have to learn this reaction, and this reaction especially Clemmensen, Wolff-Kishner, bimolecular, these are very, very important for exam. Thank you.